Paul Dirac could reshape reality with mathematics, yet he barely uttered a word at dinner. In a Bristol home where his father forbade English at the table, isolation became routine and silence his armor. While legends echo with boisterous geniuses, Dirac's life, so strange it became his legend, remains hidden beneath equations that still rule our universe. What quiet force shaped the strangest man in science? Paul Dirac spent his earliest years behind the closed doors of a Bristol terrace at 15 Monk Road, later moving with his family to 6 Julius Road. The house was quiet, almost airless, ruled by the presence of his father, Charles Dirac, a Swiss-born teacher of French who demanded precision in every detail. Each evening, the family meal became a lesson in discipline. Charles insisted that Paul speak only French at the dining table. Any slip in grammar or accent brought swift correction, sometimes met with denied requests or forced silence. There was no room for error, and even less for comfort. While his mother and siblings ate together in the kitchen, Paul sat alone with his father in the formal dining room. The arrangement was deliberate. Charles believed that isolation would sharpen his son's mind and that language, properly mastered, was the gateway to success. Conversation was not encouraged unless it demonstrated perfect fluency. If Paul felt unwell or stumbled over a word, he was expected to endure in silence. Meals became exercises in self-control, where the smallest mistake could mean being dismissed without finishing his food. Letters from this period, preserved in family archives, show clipped exchanges between father and son. Charles's handwriting, neat and unyielding, criticized Paul for insufficient effort in French. There are no records of warmth or praise. Instead, the correspondence reveals a strict regime that left little space for affection. Paul's sister Beatrice later recalled that the house felt like a virtual prison, emotionally cold, with rules that could not be questioned. School reports from the Merchant Venturers Technical College noted Paul's academic excellence, but also his emotional reserve. Teachers observed that he rarely spoke, even when called upon. At home, the pressure to avoid mistakes led Paul to embrace silence as a form of protection. He learned that words could be dangerous and that quiet was safer than risk. Years later, Dirac would say he never knew love or affection as a child. The habits formed in those Bristol dining rooms, solitude, reticence, and a relentless drive for precision, became the foundation of his adult life. In the shadow of his father's rules, Paul Dirac's world narrowed to a single point: the safety of silence. In October 1923, Paul Dirac arrived at St. John's College, Cambridge, carrying little more than a bicycle and a stack of notebooks. The city's ancient courtyards and echoing stairwells offered a new kind of silence, one he welcomed. College life pulsed with conversation, but Dirac kept to the edges. He attended lectures, but rarely joined the informal gatherings in the common rooms. When he did, he remained quiet, his eyes fixed on the floor or a distant window. Colleagues soon realized that small talk held no appeal for him. At the Kapitsa Club, a dining society for young physicists, Dirac would sit through entire meals without speaking unless addressed directly. His responses, when they came, were brief, sometimes so literal that they startled his companions. On more than one occasion, a question would hang in the air unanswered, dissolving into awkward laughter. The physicist Pyotr Kapitsa, both amused and baffled, once joked that the smallest measurable unit of speech was a Dirac, 1 word per hour. The label stuck, half in jest, half in admiration for Dirac's discipline. His daily routine at Cambridge was as precise as a laboratory clock. He rose early, cycled across town in all weather, and worked alone in his rooms or the library. Meals were often solitary affairs, taken at odd hours to avoid the bustle of the dining hall. In the rare moments he joined others, he listened more than he spoke, rarely volunteering an opinion. When conversation drifted to politics or gossip, Dirac would withdraw further, sometimes rising and leaving without a word. He was known for his discomfort with social conventions. At formal dinners, he followed the rules but never engaged in the easy banter that animated the tables. Even among fellow mathematicians, he seemed out of reach, his thoughts moving in a world apart. Some saw him as cold, others as a kind of ascetic, devoted to a higher order of logic. Yet behind the reserve, there was no hostility, only a relentless focus, shaped by years of learning that words could be dangerous and silence safe. Within the walls of St. John's, Dirac found the freedom to live by the habits forged in childhood. The college traditions of autonomy and privacy suited him. Here, no one forced him to speak. No one demanded explanations for his solitude. The world narrowed again, this time by choice, as he turned inward, preparing for the work that would soon redefine physics itself. In 1928, Paul Dirac published a paper that would alter the course of physics. Working alone in his Cambridge rooms, he set out to solve a problem that had defeated even the brightest minds of his generation: how to reconcile the new quantum mechanics with Einstein's special relativity. The existing equations, elegant in their own right, broke down when pushed to the speed of light. Dirac believed that mathematics, if followed with absolute fidelity, could reveal a deeper order. His approach was methodical. Day after day, he filled his notebooks with equations, searching for a structure that could describe the electron's behavior without contradiction. The breakthrough came when he introduced a new kind of mathematical object, the spinor. This allowed him to write an equation that was both linear in time and space, preserving the symmetry demanded by relativity. The result was compact, almost spare. I gamma mu partial mu minus me almost psi equals 0. In this single line, Dirac had unified two pillars of modern science. The equation accounted for the electron's spin, a property that had puzzled physicists for years. It also predicted something no one had anticipated: solutions with negative energy. At first, these seemed nonsensical, mathematical ghosts with no place in the real world. But Dirac, true to his instincts, trusted the logic of the mathematics over intuition. He proposed that these negative energy states might correspond to new particles, as real as the electron itself. The 1928 publication was dense, stripped of speculation or flourish. Dirac offered only the mathematics and its consequences, leaving interpretation to others. For him, the beauty and consistency of the equation mattered more than any attempt to fit it into existing ideas. In the quiet of his study, he had written an equation that hinted at a hidden mirror world, one waiting to be discovered. In the summer of 1932, a thin track appeared on a photographic plate in Pasadena. Carl Anderson, studying cosmic rays in a cloud chamber, measured the curve and found a particle identical to the electron, but with a positive charge. The positron, predicted by Dirac's mathematics 4 years before, had entered the world of experiment. The proof was undeniable. For the first time, a particle emerged from an equation before it was seen in nature. Physicists gathered at the Solvay conference that October, some still uneasy with the idea of negative energy solutions. Einstein, who valued mathematical clarity but distrusted quantum randomness, offered reserved praise. Bohr, ever the interpreter, admired the logic but found little comfort in Dirac's silence. Schrödinger, who shared the Nobel with Dirac the following year, acknowledged the achievement but favored intuition over abstraction. Their conversations were careful, sometimes tense, always respectful. Dirac, unmoved by debate, let the mathematics speak for him. In December 1933, Dirac traveled to Stockholm. The Nobel Prize citation honored his discovery of new productive forms of atomic theory. At the ceremony, he delivered a brief, measured speech, focusing on the foundations of quantum mechanics. There was no celebration in his words, no outward sign of pride. The applause faded, and Dirac returned to his solitary habits, unchanged by the world's recognition. For him, the equation remained its own reward. Long after Dirac's silence has faded, his equations still predict the behavior of every electron in the universe. In a world built on noise, his work proves that quiet minds can leave the loudest marks. The strange often shape reality more than we dare to imagine.